This slide has the chart from the graphical solution sheet of the leg3 underscore LP underscore example Excel file right here. That's the same chart, so it's going to be a little easier to see here. Okay, and shows many things simultaneously. It's a busy chart, as you can tell. I will first use this chart only to talk about the graphical formulation of the two product mix linear programming problem, and then we'll switch to Excel to reinforce these concepts further and essentially go back and forth between the two. To begin with, let's emphasize the fact that any point on the graph represents the amounts x1 and x2 of each drug. The horizontal axis, take a look at it, represents the number of pounds of drug 1, or x1, with the vertical axis representing the number of pounds drug 2, x2, to make or produce. You intuitively understand or feel that some of these points are feasible to produce and some are not. For example, if we decide to produce 3 pounds of drug 1 and 4 pounds of drug 2, so go up to 4, which is about here, right about here, okay? It's clear that we do not have, either enough of labor or material to do so, okay? So this point is called an infeasible solution. Okay, so switch back to Excel to literally see that and type, I'm going to zoom in so you can see, type 3 for X1 in cell F4 and then 4 for X2 in cell G4. Okay, as you're doing that, the worksheet will of course recalculate and you will see that you need 24 hours of labor for that production plan, production schedule 3,4, okay, which is twice as much as you have. Okay, it also shows that you would need 11 pounds of material, raw material, which is almost twice as much as you have, which is 6. The profit of 18 is said to be unattainable, and the production plan 3,4, this pair is called infeasible solution, as I indicated earlier. Okay, the two calculations used to determine the amount of labor and material you need are contained within blue cell F6 and red cell F8 here. Okay, double click on F6 to show the formula, which says equal B6 times F4 plus C6 times G4. Again, B6 is 4, okay, C6 is 3. You should think of F4 and G4 as the current values of the production vector X1, X2. So, which currently have the values of 3, 4, which we know are no good. So, in math terms, this is then 4, okay, times x1, okay, which is this, plus 3, which is in C4, times x2, right? Where x1 and x2 are in these cells F4 and G4 and have currently values of 3 and 4. Okay, so this is then Excel equivalent to the formula on the top of the previous slide, 4x1 plus 3x2. Okay, so whatever this amount turns out to be, 4x1 plus 3x2, which is again the same as this, right? It has to be less than or equal to the 12 hours that are available. And those are shown here in cell D6. Okay, which for 3-4 production plan is clearly not the case, right? If you use x1 equal to 3, that's 4 times 3 is 12 plus 3 times, if you use 3 for x2, that's 3 times 4 is 12. So we got 12 plus 12 is 24, which is why we get that number here, which is clearly violating that constraint. Okay, this whole same shebang is repeated here for the material constraint, right? Okay, where it takes 1 pound of raw material to produce a pound of drug 1 and 2 pounds of raw material to produce a pound of drug 2. So we have B8 times F4, which is to say 1 times X1 or just X1 plus C8 times G4, which is to say 2 times X2, right? Which is then equivalent to this left-hand side of the material constraint, X1 plus 2X2. Again, whatever these X1 and X2 production plan turns out to be, has to be less than or equal to 6. So with X1 is 4, and X1 is 3 and X2 is 4, we got 3 plus 2 times 4 is 8, which is 11, which is clearly violating that constraint. Okay, so we'll switch back to Excel. So take a moment to review these formulas, all right, so you understand how how they relate and how they come from or are equivalent to these two left-hand sides of the labor and material constraint in the mathematical formulation. The third formula, the profit function or objective function 2x1 plus 3x2, is implemented in cell D6. Okay, D6, which says essentially 2 times x1, which is in F4, right, plus 3 times x2, which is in G4. That's the 2x1 plus 3x2 objective function, which is currently 18, and we already said that that profit is unattainable. Okay, so what we'll do, we'll now try a couple of other more subtle violations compared to this one, which was obviously out of the ballpark, almost literally, right, in the top right corner of the screen. Okay. For example, what if we decide to produce only 4 units of drug 2 without producing drug 1 at all? So 0 here. Okay, we still can't do it, right? Because you can see that we have enough labor hours now here, 12. That's simply because each pound of drug 2 takes 3 labor hours times 4 is 12, so we have enough hours, okay? But we don't have enough material because each pound of drug 2, there's 4 altogether, takes 2 pounds of raw material, so 2 times 4 is 8, which is 2 pounds. We are 2 pounds short. Okay, conversely, we may decide to produce, I don't know, 2 pounds of each drug. So 2 here and 2 here. Okay, we can't do that one either. Now, but now the constraint that's violated is labor rather than material in the previous example. Okay, so again, the total amount of labor hours that is needed is 4 times 2 is 8 plus 3 times 2 is 6, which is 14. Okay, we only have 12, so we are 2 labor hours short. However, notice that we have exactly the amount of raw material needed to produce these 4 units, 2 pounds of 4 pounds, rather 2 pounds of drug 1 and 2 pounds of drug 2, because 1 times 2 plus 2 times 2 is 6. Okay, so we'll continue looking at this chart, right? So the 2-2 solution was over here, right? Right here. So it was right on the material constraint, but well above the labor constraint. So we'll continue looking at these different solutions to learn more about this graphical formulation of the linear programming model in the next video.